Okay, just before we start, Matt. Can I just say one thing? Can I just get the floor for Q&A, and then I'll jump straight in. Just as a report back on the last Q&A, because there's some questions that people asked me that I may have cocked up, and that people had asked me and I didn't have the answers to. So very quick ones, and they're aimed at you, Matt. All right. For some reason, I referred to the lysine engine as a parallel processing engine. It's not. It's indexing, and I can't understand what it is that made me say that. It's something that I use in Neo4j. It's something that I use under the hoods. It's in RavenDB. It's in a whole truckload of information. So if I'd given you a bum steer, all right, stupidly looking at the notes on it, going, why on earth did I say that? And your other question for me was on full text search in MongoDB. It is coming out in the latest version. All right, so okay. So the newer version that was coming out, I think it's version 2. I'm not sure on the version number, but that's definitely got full text search in it. All right, cool.
Cool. Yeah, it's an infrastructure question more with NServiceBus. Actually, 3 years ago, we implemented ServiceBus everywhere, and for the reason that you gave, well, this is with my previous company, for the reason that you gave, it was really quick development time, was easy to use, transactions, and we ended up canning it just because when it became to deploy and moving out from, through QA and UAT and everything, we had so many issues with MSNQ from a permissions point of view, all sorts of trouble that we found with it. I kind of just wanted to know, how's your experience been with implementing the newer version of NServiceBus? Has it been
okay, so my experience has been like yours on version 1 and 1.9 and version 2. A lot of experience down in that area, and I can say to you categorically, it is a frustration to get those earlier versions to be able to work. But once you know the tricks, and if you want to talk to me about those tricks, I can tell you what those tricks are. Once you know those tricks, you can sail through them quite quickly. And I think we banged our heads enough times in our local environment to be able to move them to client's production environment, that I think pretty much every one of my senior developer knows every one of those tricks on the back of their hand. Check for this, check for this, check for this, because it's not an easy thing. NServiceBus is not reporting to you where it's having problems, and it just messages don't get handled, or you think the queues, and it's always got to do with security. It's never got to do with anything under NServiceBus. It's got to do with permissions and security on that particular machine. In terms of where they've gone to now, I found that setting up this particular demo, this running on NServiceBus 4, on just a normal trial version, it was trivial. I basically started the buses, got them going. I think the only trick for me in this particular case was it used the bus based on the name of the component, which I didn't like, and that caused some trouble for me. But just setting up the endpoint, saying configure with, I want customization, I got over that quite quickly. All right, that's a good question.
Chris, can you repeat the questions?
All right, sorry. Can you just pass that back?
Okay.
All right, that is a particularly delicious beer. We just found it about a month or 2 ago. All right, anybody else?
Yeah, we've got chocolates.
Yeah, we do have chocolates, and we got T-shirts if you're a medium.
I've had limited exposure to the SOA environment.
Yeah.
In the design role that I was involved in, I struggled quite a bit with putting a common information model together to sit inside the bus. Have you had any experience? Do you use a common information model that's based?
So the question is, do we use common information model? And I'm on the back foot, so you need to explain or describe common information model to me.
So we've got your multiple ERP systems, and,
Yeah.
and they all got their own definitions and naming structures for the tables and the objects. In the bus, you want a single agreed information structure.
All right.
That translates those different
Okay.
names into
I'm getting the problem here. Okay, so the question is, we've got different types of systems, and on the bus we have to be able to accommodate those different types of systems, and they've got different naming conventions and different kinds of. I would hazard to say that you're probably not working with a complete SOA solution. You're working more with an integration solution. Okay, so this is, and I didn't want to start dissing technologies, but there are technologies that brand themselves as SOA, and then when you unpack them, they're actually integration technologies. All right, there's probably BizTalk. Sometimes not, depending on how you use BizTalk, could actually give you that problem. So that's an integration problem more than it's a SOA problem. And you've probably now got more experience to understand how I could implement integration and how I could implement sort of a more SOA type technology. That's more integration. And you're going to hit that problem. You're going to hit that problem. You're going to need filters. You're going to need routers. You're going to need lookups. You're going to need a lot of very fiddly pieces of thing to be able to get that working. It's not pure play SOA. All right. So that's where the problem comes. Good question. And a good Next one.
I think it was problem 2 and 3.
Yes.
There were two issues that you raised. First with the temporal decoupling.
Yes.
And secondly with the problematic retries where you need your transaction processing.
Okay, so let's quickly go through problem 2, processing engine.
Sorry, I think it might have been the previous.
Next one.
Previous. There.
Okay.
So in almost all of them, you have that problem of the temporal decoupling and also the error handling, so the retries, the transaction,
Yes.
etc. And before you mentioned the bus solution, I was thinking that in my experience, what I've seen in industry as a solution
Right.
to that kind of architectural problem is to use a state machine.
Yes.
So that you can store the states, you can have triggers that move to a different state, code is then executed, and so on and so
That's right. That's right.
And so I've never seen that NServiceBus before, but judging from what you've mentioned, I'm not sure if it is a full state machine. You mentioned that it's, for example, only recently has the functionality to have a second level retry, etc.
All right. So I can answer that question for you quickly. So the question was, wasn't so much a question but a statement, was in industry, the best way that they've used for this temporal decoupling, where things have taken a very long time to run, is the concept of a state machine. So you walk through a series of steps to be able to achieve this thing called the long-running transaction. So the first thing I need to say is that none of these things are long-running transactions, not that long. Well, they are fairly long-running, but they're not a number of transactions that I need to do. I need you to do this for me, and then get the result back again. So it's a one-end state. So I probably wouldn't want to put it into a state machine. But that's not saying that your problem doesn't exist. It does exist. And NServiceBus has a solution for you. And I didn't get onto it because it's probably one of those cool features that didn't make the cut in the last edit last night. Is they have this concept of a saga, and a saga is the state machine, and it's a known SOA pattern. So basically, you can step through a series of states, and when certain things happen, NServiceBus goes and pulls the saga out, checks to see where you are in that saga, saves the state away, and pushes it back into its Raven DB, and then carries on working. Yeah.
Sorry, is there a reason from an architectural reason why you would then go for, in that situation, NServiceBus as opposed to something like Windows Workflow Engine?
No. But I've been burnt by Windows Workflow Engine, so I don't touch it. So I wrote an entire system that did exactly what you did in version 3, and then they rewrote version 4, and I was sitting going, oh, okay, throw the code out.
But it's a lot stabler now.
Exactly. And I'm not going to diss it because I think it is in a very good place, but I think I've had this bad taste in my mouth, so we've moved past it. I could use it. It's got state machine in it. I think the only concern, and the thing that I have heard, is that when you create your own activities, they run as static state. And so you've got people sharing, cross-cutting parts of your in large high-end transactions where things are running as static and it's available to everybody. I don't know. I don't like it. I don't think it could handle a very high-end solution. So I think it could end for low-end. But some of the feedback that I've had from people that are using it, I've tended to skirt it a little bit. But you could use it. I'm not saying that you can't. Again, it's not about the technology. It's about trying to find the solution to your problem. That's a good question. Beer? Chocolate. I can throw these. Much better. Varun.
When the exception is thrown in a specific component or module as part of the NServiceBus solution,
Yeah.
is that transaction rollback propagated throughout all components? All connected components to the system?
Yes. Okay. So the question is, when a system rolls back the transaction, does that transaction rollback happen for all components? And I'm going to ask Varun to just clarify what does all components mean. Does that mean all connections to the database?
Yeah, all subscribers.
Or is that all subscribers? All right. Varun, it's a good question because that was part of my demo number 4. Again, it's lying on the cutting room floor. Demo number 4 is basically I wanted to be able to have a break in some process and show you exactly what happens if it broke in the subscriber. So what would generally happen is you're trying to isolate the process that you're focused on. So the command would have done what it would have done, and it would have broadcast to the subscriber. When it broadcasts, it actually puts it into the queue, ready for puts it into all the other subscribers' queues, and says, "Here's something for you to do." When it fails on the subscriber side, the subscriber just pushes it into the error queue, and then you resurrect it and bring it back into its queue. So it's not affecting anything else on the side that actually published it, because they're all running on separate queues, and because they're all running in their own sort of scope. Nothing inside the system is touching each other. If you had that problem, you've got more than a you've got a bigger problem to be worrying about, where a transaction in the subscriber can fail something inside the publisher. Does that answer your question? Yeah? Question?
Chris, I'm just trying to think on when to use service bus, when not. In your example where you're capturing a username, you captured a name and a surname,
yeah,
and you automatically created the username
yeah,
simply based on the name.
That was just simplicity.
Yes.
Okay.
So in that example, if you then send the name and surname to your database, you obviously check whether that username is unique.
Yeah.
And then only you return
Yeah.
success.
Yeah. You're starting to
in a system where you need that save to be successful before the user carries on to their username, how are you going to get that feedback happening to the?
It's not an easy problem to solve. Sorry. All right. Sorry about that. The question was, in that particular example, I created a user and I created the username and password automatically. How would I know that I didn't recreate the user's name and password? How would I do some form of validation or some form of checking inside the system before I carried on doing my process? So the short answer is sometimes you don't care. Sometimes you're just pushing the information and putting it back out again, and you can show that information through another process. So your user can, I think one of the good examples that I've seen is booking seats at a stadium for a show. Often you don't get to choose where you sit. You just get blocks. I want to sit in that block, and then the seating algorithm will work out for you where you actually want to go and sit. So there are ways to solve that problem. But in cases like yours where you actually do want to check, I would have been checking before I'd even got to the point of putting the information on the bus. I would have checked to see, do I have that information? I would have checked to see, could I actually subscribe or hold over that particular name? And so it's not an easy problem to solve. None of these problems are easy to solve. In distributed systems, when you start working in these architectures, it's not trivial. I've shown you a very high level of what we've actually had to do. I can guarantee you, if you had a good beer with me, there would be lots of war stories. It'd come out there cut and bruised. There's lots of decisions we had to make that counted other decisions, and it's never easy to go that. But to solve that problem, I would have first checked very quick request response, and then, all right, I know that I could actually send this information before I actually put it on the bus and sent it, because at that point, it's gone.
You're using your example request reaction as opposed
Yes.
to request response.
Yes.
When you're saying request reaction, you just mean that saying, okay, I got your message, but I don't actually have a response to you.
So the question is, what is the difference between request response and request reaction? I think would be an easy way to sum it up. Request response is the standard web service pattern. I ask you a question, you give me a response. And it could be a response to my question, a more deeper meaning. It's not just I got your question, and yes, I'll take care of it. That's more the request reaction. The request reaction is I want you to do something for me. That's the request, and I'll give you a response that says I will do it for you. And the reaction will come back along another path. I'll either publish it that something actually happened, or I will call back into your system and give you the result at a later stage. That's the difference between request response and the request reaction.
Okay, so that's where you were logging it in another database, and then the client would have to poll that to see whether it's successful.
Yeah, or yeah, or full duplex, some other way of doing it. Yeah. Beer, chocolate. Question.
Yeah, just some confirmation clarification on your coordination that you talked about. So you've got parallel service hosts, right?
All right, so that was pattern number 4.
Yeah. So basically, I'm just trying to figure out, so the whole point was performance, right? Yeah, so coordinating those requests and responses.
This guy over here.
Yeah, exactly. So just need some confirmation on that. Basically, what you're saying is for performance, we're basically splitting those requests into multiple service hosts, right?
Yeah.
So one of the things was, if this, obviously you're using unit work pattern there, right? So you executed that. But how would you create those dependency between those service hosts? So for example, would service request B, subscribe to service request A? So I'm just trying to understand how that coordination would work.
Okay, so the question is just to explain a little bit more about the coordination as to how we actually, all right, I'm going to have to tread very lightly. In order to do these slides, I actually had to go to clients and go, I know this is what your system looks like, this is what I'm talking about, so I'm going to tread very, very lightly, and there's going to be areas I may not be able to talk about. So the question is, how did we coordinate these aspects? This is part of a validation process. And it's validating colossal amounts of data, and it does it very regularly. Essentially what we would do is say, okay, I need to validate this data for these criteria. And I know that those criteria come from different data sources. So I would know that this is the type of data request that I'm going, create a packet, tag it with something unique. I could use a GUID, or I could use something like, create another packet, tag it with exactly the same thing, pop it on these queues, and then when it came back, I just start tying up what I need to know, what's still outstanding, what do I need to wait for. That was the simple approach that we actually used. In this particular solution, the fact that we got a response or not wasn't super important. We just needed to, when we got the response and how we tied it back together again wasn't super important. We did do it so that we could see what was still outstanding, but it wasn't the crux of the problem. But we just used a simple process of tagging and then consolidating and then writing the information away. Because the stuff's all going to come back at different times. If you look at some of the quick checks and validations, they were going to happen, sure, a couple of milliseconds. But some of the more complex stuff, and especially on the longer running queues, those would take a few minutes before they got back again. Does that answer your question?
Sure. So it's not actually a performance. What we're saying is you've got long running tasks, so when it's short running tasks, it's obviously a bottleneck there, right? So it's not necessarily a performance decision that you're meant to take.
Well, this was performance in terms of I have to do this quickly, and I have to do it very quickly because I'm going to be asked to do the same validation 2 weeks from now. Okay, and as I said, as you start adding more and more data to this, it just becomes an exponential problem. So it was a performance thing we were trying to solve.
So independent.
Yes, but for independent tasks. And the way that we did that was I couldn't do this and then do this and then do this and do this. I'd rather go, okay, everybody do what you need to do, come back. All right. Chocolate, beer?
Beer.
Any more questions? Comments?
In terms of error handling, you went through the process where it does retries and things
Yes.
like that. Will there ever be for me it's more about the notification of the error because there's a lot of times error happens. And if it's, particularly critical error, if you want to notify that out, so that I'm guessing would be published as an event that can then get subscribed by someone, or can you then inject something in where you start, writing manual code to notify particular people, or what's the...
Okay, so the question is, in terms of an error actually happening on the network, that just went to an error queue, how on earth would I actually know about the error queue? We generally don't subscribe to sending out notifications and messages and all that kind of stuff. We generally monitor those queues. So you'd be constantly checking to see what does that queue look like. And that, for the infrastructure people, would come into one of the dashboards that they'd be worried about. And when you're worried about integration types, well, you're worried about distributed systems, this is the kind of thing that you're worried about. So you don't code that infrastructure. You get somebody else to monitor the performance of what is actually happening. So watch those queue sizes. So perfmon is a very good example of how you can actually watch the size of the queues. If you start up perfmon, you can go and say, what is the queue on the error queue? What size is it growing to? And just keep watching that part. It just can just plug straight into your overall system.
Why I specifically asked this question?
Sure.
There may be something in the host, you pick up as a particular type of error.
Yeah.
That may not be a network type of error that you may want to push off a particular.
Yeah, I can see where you're going. I honestly haven't had that problem face me before, where I could actually diagnose what the problem is, have a self-diagnostic, self-healing type system. I've really just, that's gone onto the error queue because it needs to be taken care of. Either it needs to be replayed because the system was under strain, or the data inside there was really bad and I need to clean the data, put it back on the queue, and then rerun it. But I haven't seen this particular case. Doesn't mean it doesn't exist. I just haven't seen that in real life. Sure.
So now, let's say that the error process has completely finished and it's sitting as an error that's not going to be retried. You come in as the admin.
Yeah.
How easy it is to push that back onto the original queue after you
You saw me running a batch file. I just had a little batch file that said put the information back on you. That's essentially what it is. NServiceBus comes with a return to queue tool, and it pushes it back to the queue. Vera chocolate? Another question?
Just coming back to the coordination.
Yeah.
Just say I'm creating a little workflow. So based on the response that I get back, we're either going to call service B or C. So I'm calling service A based on the response. I could either decide to call B or C. So I'm assuming you set that up in that coordinator.
Yeah.
How do you test that in terms of I want to simulate that I got a result that says we go to C, and then I'll simulate the result of that. Says I want to go to B.
It's good. It's a good question. So here we're starting to talk about testing and how do you test in these types of environments. So the question was, I have a process that does something. It then needs to decide whether it routes to B or it routes to C, and if we're doing that, how do we test it? It's an exceptionally good question. So the very first part of that, and there's a section that I didn't really talk about. I was going to get onto it, but these classes, these messages and these classes or handlers inside NServiceBus are just handlers. They're just standard C# pieces of code, and they're invoked and put in line using inversion of control and reflection. All right, so the very powerful part of that is that you could actually test those items in isolation, so that you can actually say, what does this do when I get this type of request? And you can create a command, just new up a class, set the values, push them straight into the object or the handler, and just hardwire the handler and the command right to each other and test it that way. So it's an easy way to get into that sort of unity kind of testing problem. In terms of the routing, you'd have to decide what is the business criteria for going to that point or that point, and you could daisy chain those. You could write a test harness that could be able to do that for you. Does that answer your question? When we're doing early development, we actually do that. We don't actually have the service bus in at all. We just start writing the handlers, writing the commands, and then creating just test jigs that could new up an item, push it in, test that it's actually working. All NServiceBus gives me is a piece of infrastructure to be able to work on a queue, to be able to retry, to be able to second level retry, to be able to audit. It's got a whole variety of things. It doesn't mean anything to the business case. So that's the way that we would generally do it. Does that answer your question? Cool. All right, guys, it's been a good day. Thank you very much for your time, and hope to see you at the next one. Thanks very much.